Now let us discuss about the product formula. The product formula for phi of. Product formula for Euler-Torsion function. What is the product formula for phi of? Phi of n is Euler-Torsion function. So the theorem says that for n greater than or equals 1, phi of n equals, we have phi of n equals n into product p divides n 1 minus 1 by. So this is the product formula for Euler-Torsion function. This is again an important result. This is used to find out the value of the phi function for n when it is expressed as the product of distinct primes. For n greater than or equals 1, our result is phi of n equals n into product p divides n 1 minus 1 by p. How to prove? The proof is in this way. When n equals 1, what happens here? When n equals 1, what about this product? When n equals 1, the product is empty. Why? Because there is no prime factors which divides 1. When n equals 1, we have phi of 1 equals 1 into product p divides 1 into 1 minus 1 by p. But p divides 1, there exists no such primes which divides 1. P divides 1. No such primes. There exists no such primes which divides 1. Therefore, this product should be empty and its value is treated as 1. Therefore, phi of 1 equals 1. That is the assigned value of this phi function. When n equals 1, the result is immediate. Okay. When n equals 1, product is empty and the assigned value is 1. So, it is phi of 1 equals 1. Why? Because there exists no such primes which divides 1. No such prime. So, that product is treated as empty. So, the assigned value is taken as 1. Agreed. Now, suppose when n greater than 1. When n greater than 1 and if this n is the product of distinct primes, p1 etc. p. If n is the product of distinct primes, p1 etc. pr, instead of here pr, then the product p divides n 1 minus 1 by p can be rewritten as how? When n greater than 1 and n is the product of r distinct primes p1 etc. pr, then this product p divides n 1 minus 1 by p can be rewritten as it is product I ranges from 1 to r. How many factors are there? There are r prime factors. Product I ranges from 1 to r. 1 minus 1 by pi. Okay. Product I ranges from 1 to r. 1 minus 1 by pi. You can expand this. Product I ranges from 1 to r. 1 minus 1 by pi can be rewritten as it is 1 minus, it is 1 by p1 into 1 by p2. Suppose r equals 2. What do you get? It is 1 minus p1 into 1 minus p2 when r equals 2. Okay. So, you can expand it. 1 into 1 minus 1 by p1 minus 1 by p2 plus 1 by p1 p2. Okay. So, it is 1 minus of 1 by p1 plus 1 by p2 plus 1 by p1 p2. Agreed. So you can generalize this part. 1 minus p1 into 1 minus p2 into 1 minus p3 into etc. into 1 minus pr. What you get? It is 1 minus. It is actually 1 minus sigma 1 by pi where I ranges from 1 to 2 plus 1 by p1 p2. Okay, so you can extend. Suppose there are 3 factors. What do you get? Then it is 1 minus sigma I ranges from 1 to 3 1 by pi. Then there is p1 p2 p2 p3 and p1 p3 terms are again there. Taken 2 at a time. Finally, there is 1 by p1 p2 p3. Okay, so it is generalized. It is 1 by it is 1 minus sigma 1 by pi plus 1 minus sigma 1 by pi, then plus sigma 1 by pi pj, okay, minus sigma 1 by pi pj pk plus etc. plus the last term is 1 by p1 etc. pn. Like this, you can expand this product. So you will have this 1 minus sigma 1 by pi plus sigma 1 by pi pj minus sigma 1 by pi pj pk and so on. What is actually sigma pi pj? Means these two taken 2 at a time. Here these 3 pi pj pk, they are taken 3 at a time and so on. Okay, right. Also, each term on this right side, 1 minus sigma pi plus sigma pi 1 minus 1 sigma pi pj sigma pi pj pk etc. Each terms on right side is of the form plus or minus 1 by d, where d be the divisor of n, which is either 1 or product of distinct primes. Okay, each term, come to each terms on right side of this equation. What you get? The first term is 1. When d equals 1, it is 1. When d equals p1, p2, p3, it means taken 1 at a time, that is sigma pa. When d equals p1, p2, when d equals p1, p2, p3. So each term on right side is nothing but is of the form plus or minus 1 by d, where d is either 1 or it is the product of these distinct primes. Now, the numerator here plus or minus 1 by d. What is actually plus or minus 1? This plus or minus 1 by d is obtained from where? Mu of d. By when, mu of, yes, it is mu of n. When n is the product of distinct primes, we know that when n is the product of distinct primes, then what is mu of n? Mu of n equals minus 1 power k. This is by the definition of Mobius function. Here, this plus or minus 1 is nothing but that is coming from where? This Mobius function. So instead of n, here this d is suppose p1 etc. pr, then this plus or minus, mu of d equals plus or minus 1. Therefore, we know that this product p divides n 1 minus 1 by p equals plus or minus 1 can be written as it is mu of d by d. There is a summation. Okay. So it is sigma over d divides n, it is mu of d by d. Clear? Why? Because each term on right side is of the form plus or minus 1 by d, and plus or minus 1 is coming from the definition of mu of d. So it is this can be rewritten as it is sigma over d divides n, mu of d by d. Listen, when d equals 1, it is 1. When d equals p1, p1, it is sigma 1 by pi and so on. Okay, because mu of d is, when d equals 1, mu of 1 is 1, it is 1. Enough. When d equals p1, so it is mu of p1, that is 1, 1 by p1 plus 1 by p2 plus 1 by p3 and so on and so on. So that equals, it is 1 by n into, you can introduce this 1 by n, so 1 by n into sigma d divides n, mu of d into n by d. You can introduce 1 by n and n simultaneously. Okay, so that equals 1 by n into sigma over d divides n, mu of d into n by d is nothing but phi of n. Why? Because that is the relation between this Euler torsion and Mobius function. We know that when n greater than or equals 1, phi of n equals sigma over d divides n, mu of d into n by d. So it is, so finished. That is product 1 minus p divides n, 1 minus 1 by p is 1 by n into phi of n. That means phi of n equals n into product p divides n, 1 minus 1 by p. So this is the product formula of this Euler torsion function. Agree? The relation is, this theorem is again important. For any n greater than or equals 1, then phi of n equals n into product p divides n, 1 minus 1 by. So we know that for any n greater than or equals 1, phi of n equals n into product p divides n 1 minus 1. Okay. So what is phi of p power alpha? Where p is prime, what is p? P be a prime or p be a prime and alpha greater than or equals 1. So what is phi of p power alpha? You can replace n by p power alpha there. So in this result, in this equation 1, replace n by p power alpha. What you get? For alpha greater than or equals. So this result 1 gives, it is phi of p power alpha equals, it is p power alpha into product p divides n, product p divides p power alpha. There is only one term. Okay, why? Because p divides p power alpha. So it is 1 into 1 minus 1. Agreed. So it is phi of p power alpha equals p power alpha into 1 minus 1 by p. That equals, you can multiply it. It is p power alpha minus p power alpha minus 1. Okay, so the result is immediate. P power alpha into 1, p power alpha minus p power alpha into 1 by p, p power alpha minus 1. So for any prime p and for any alpha greater than or equals 1, phi of p power alpha equals p power alpha into 1 minus 1 by p. Agreed. So this is another result. Now again, we know that phi of n equals this one. So what is phi of mn? Phi of mn, where m and n are not relatively prime. M and n are not relatively prime means suppose they have a GCD D. So what is phi of n? That's again an interesting research. How to find out this phi of mn here? We know that phi of not m comma n, phi of mn into e, phi of m. By according to this argument, what is phi of mn? Phi of mn equals mn into, yes, its product p divides mn 1 minus 1 by. Okay, that means phi of mn divided by mn, bring this mn to the left side, equals product p divides m into n into 1 minus 1 by. Clear? Now listen. Here each prime divisor of mn, either it is a prime divisor of m or it is a prime divisor of n. Also, those prime divisors which divide both m and n will divide this GCD of m and n. Clear? Each prime divisors of mn, p divides mn. So each p is a prime. Each prime divisors of mn that divides either divides m or divides n. If this p divides both m and n, then it should divide its GCD. Okay, so this can be rewrite as as p divides n means product p divides product p divides m 1 minus 1 by p into product p divides n 1 minus 1 by p, all divided by product p divides GCD of m and n 1 minus 1 by p. Why? Because if p divides mn, then either p divides m or p divides n. But if this p divides mn, both m and n, then its p divides its GCD. So there is one term exceeds there. So these terms are exceeds there. So excess there. So in order to adjust them, you can divide such terms. Okay, right. So that equals, what is product p divides m 1 minus 1 by p? It is phi of m by m. Okay, by definition, phi of m by m into phi of n by n, all divided by, here P, what is Mn? Mn is D. P divides D. Since P divides D, it is phi of D by D. Clear? That means phi of Mn by N equals, finally, yes, it is phi of Mn by N equals, Mn equals, it is phi of M into phi of N by Mn into D by phi of. Okay, this Mn cancelling each other. So, if M and N are not relatively prime, then we get a new result. Phi of M into N equals phi of M into phi of N into D by phi of D, where D be the GCD of both this M and N. Okay, this is an interesting result, and this can be proved by using these arguments. Okay, thank you.